Hello everyone. My name is Naotoshi Osaka from Tokyo Denki University. Um, this year, uh, I am very much looking forward to visiting Taiwan because I am going to visit WOCMAT recently every year. But as you see, because of COVID-19, uh, not only Japan, all over the world is suffering from this COVID-19. I really hope that the next time I have also chance to visit here, Taiwan. But this year, it's a pity that I cannot visit Taiwan. So I'm now sending a video, and I hope uh, you could appreciate what I'm going to talk about. Now I will share. So today I am going to talk about a new room acoustic effect based on an auditory illusion. And I'm from Tokyo Denki University. Introduction. Uh, Commercial audio system, 5.1 channel, 9.1 channel are now available. So various acoustic environment is very useful for us and very popular. And at the same time, more of rich expressions are expected. So we are pursuing a new acoustic effect. General concept of sound field in room acoustics. Please take a look at the left one. I draw using the 4 channel system. Ideally, inside the surrounding system, a homogeneous perception is expected, but actually it doesn't happen. And in reality, a very sweet spot, a narrow spot is realized, and you cannot uh, extend to the larger space. And I would like to talk about the specification of the new acoustic effects that we are pursuing. Uh, we think that it should be easily realizable in ordinary halls, rooms, using commercially available multi-channel speaker system. I'm not trying to deny the very specific environments, say using 60 or 200 speakers. It is fine, but what I'm saying is it is very rare and you have to visit a particular place to perform your own piece. But now we should also pursue and find the more popular place so that easily re-performed and easily the piece to be heard or played. So on the contrary to the general idea, not spatially homogeneous hearing, we do not expect the very homogeneous, the same hearing placed within throughout the room. That's fine. Rather, the different timbre should be experienced. Please take a look at this diagram I draw using the 4 channel sounding system. Then you can hear uh, timbre A here, timbre B here, timbre C here, timbre A here. So you experience in this diagram 3 timbres. Or if you are sitting in the particular place, the audience does not experience the same timbre. The audience, according to where you sit, they experience different timbre. So different timbre heard according to the listening position. But how is it realized? Uh, Last year, our labs, we discovered uh, an new auditory illusion. And we call that, we name sound stream Moore phenomenon. What we did, firstly, we decomposed the sound. Supposing this is a sonogram of a speech, and this is 1, 2, 3, 4, 5, the harmonics. And this one, odd numbered harmonics are extracted. And this one, even numbered harmonics are extracted. So they are heard differently. And by using these decomposed sound, we made a phenomenon. More specifically, please listen to this sound. This is the original speech.
爆音が銀世界の高原に広がる。爆音が銀世界の高原に広がる。
This is a Japanese speech of a female, and this was the pitch of the sentence is almost maintained kept the same because we ordered don't have the intonation. 爆音が銀世界の高原に広がる. So this is 220 of a female voice, and we extracted harmonics using the sinusoidal model MQ algorithm, which is one of the major two algorithms. Another one is SMS, but we used MQ algorithm. So if we get together the even numbered harmonics, this is how it is heard. Once again. As you can recognize, this is 1 octave higher than the original pitch, and this is odd numbered harmonics and residuals. From now on, I just omit saying residuals.
爆音が銀世界の高原に広がる。
The pitch is the same as original, but because we extracted this one, the timbre is different.
爆音が銀世界の高原に広がる。
This is original.
爆音が銀世界の高原に広がる。
So the red one represents even numbered harmonics, and blue one is odd numbered, and these are very small one, residuals. So anyhow, we decomposed speech into two parts, and we asked the subject. We did the subjective test. It's a subjective evaluation test on degree of grouping. Degree of grouping, how much the sound grouped and heard only one. So decomposed sounds are assigned to L and R speaker respectively. So even number here and odd number harmonics assigned here. And listening position of the subject placed either of 5 positions, 1, 2, 3, 4, 5, linearly spaced. So this is the sounds you just heard, and also we have prepared another pairs of either the same and different with a different instrument, or 1 octave higher. Please listen first. This is flute sound of tonguing. Once again. Oops. Sorry. Piccolo. Flute. Oh, this is one pair, so decomposed one. Outflute, melody, the flute. The flute. Piccolo, 1 octave higher. So we have prepared the composed pair or completely different instrument sound pair, either 1 octave higher or the same. So these pairs are tested if it can be grouped as one or not. And in order to have the subjective evaluation test, and degree of grouping is defined as follows. We did a 5 category test. So subjects are supposed to score 1, 2, 3, 4, 5. Either they have to grade from 1 to 5. And mean score is defined as degree of grouping. The subject of 15 people age of 20. So 1 represents, well, you can hear 2 separate sounds, and 5 is defined as only 1 sound is heard. So it's statistically exists, and you can score grouping and separation. So this is the result. I do not go much in detail, but there are many pairs that you heard already. I don't introduce what pair it was in precise, but what we can hear is that this one is left, the source is B and source is A. And this is the completely, we switch it. I change the side and source A and source B. We take a look at this one, source A, source B. So the result is, if you go to one side, which is 1 octave lower, this is 1 octave higher, then the higher pitch, the sound of higher pitch are always decomposed, separated. And this one is according to the pair, but still it tends to be grouped together. So within this graph, this is not symmetric. But if you change the side A and B, then total graph attitude is the same. Oh, not same, symmetric. But it's not symmetric at the position of number 3. So what does it symbolize? Now, this is the direct answer. We asked subject to move around. Please listen to this sound. This recording is left side speaker, and this camera and microphone is this the same, and it moves from left to right. Please listen to how this sound. The point of this demo is at the last you can perceive only one sound or with the pitch of the same as the original. But in the left side, you could hear two sounds. Please repeat this, not from the beginning, but up to the borderline. Okay. Be aware that you can hear two sounds of one octave higher and also the pitch of the original, two separated together. Past the borderline. So we did another test or experiment. There's a speaker L here and a speaker R here, and even numbered harmonics are assigned here and odd numbered here, and subjects are requested to walk around here from left to right, right to left, and, or go back and forth. And you are requested to find the borderline. So this is the borderline of separated heard place zones and also grouping zone. So this is the, in average, 172.5 centimeters. So this is not exactly the center, but closer to the L channel. So as a demonstration, you can hear there is a definitely two separate zones, separation and grouping. So we would like to generalize of the sound stream Moore phenomenon. Firstly, we have to decompose sound stream. Sound stream means a sound which you can admire only one sound. The condition that each of the decomposed parts are also perceived as a sound stream. That means not every possible decomposition is good. If you decompose a sound, each of which should be heard as another sound stream, this is a very difficult task or condition. And also, you assign each sound to different channel. In stereophonic hearing, then one is left, the other is to the right. So this is the sound Moore phenomenon. And we could expect other decomposition methods. Last year at WOCMAT2019, I talked about the sound colors. This is NMF based, and this is target sound represented by elemental sound. And application to this phenomenon to room acoustic effect is sound stream Moore representation we name. So this is interference fringes of timbre in multi-channel sound field. So from one speaker like this, from another speaker like this. So this is the original definition of Moore. but we named after this phenomenon because in the sound field, different uh, interference uh, ranges of timbre can be perceived. So if we use the sound collage decomposition, I would like to show you some ideas. So this is a default portrait. The definition is target. Target means here it's a portrait is expressed in terms of elements like fruits, flowers, and etc. Vegetables. So in sound case, this is target sound. Please listen to. This is a cicada. It's the name of species I don't pronounce. Please listen. I'm not sure if this cicada exists in Taiwan, but in Japan it is very typical cicada. So we would like to express this sound using those three sounds, say violin, violin's glissando, down, up, and also glockenspiel. And we decompose this sound using those target sound. We decompose target sound using this elemental sound. So supposing this channel 1 comes from only the violin sound, violin say glissando down sound, or I wrote flute, but supposing this sound. And this one is glocken. So always decomposed sound is assigned to particular sound, channel. But inside, in the central place, what you hear is like this. So in the central place, you hear the target sound in terms of elemental sound. But if you come closer to each channel, you can hear the elemental sound. So this is a possibility of another sound stream more. So we would like to pursue this possibility. So now today I introduced a new room acoustic effect, sound stream more. So this is based on new auditory illusion. Speech is decomposed to even-numbered harmonics and odd-numbered harmonics. And a listener can perceive the clear boundary of two different timbre zones. So this gives the possibility of application to room acoustic effect. So for future works, we try to also pursue another possibility of decomposition. Oh, thank you very much. I certainly thank Jeff Huang and also people who organized WOCMAT. Thank you very much.